So in production, very likely, I would say like 100% of certainty on this, you're going to receive geometry. The other departments like modeling will model a beautiful desert that it will have all the characteristics of the vision of the director. But for the purpose of this tutorial, since I don't actually have any modeling of a 3D model of the desert, I'm following this tutorial that is great. I encourage you to go here, type bizarre self-production, Google it, or Google the whole. I'm giving you the whole link on the lower third of this part of the video. Follow this. Basically, that's what I did. It's a simple thing using high fill. You can use the high fill node. I'm using the grid, very small grid spacing. The orientation is Z and X, and size is 2000 by 2000, and this is giving me something really large. Then append a high fill noise, use a high amplitude for 150, same size for the element size. Well, offset is just giving you different kind of like looks, but in this case I'm using minus 500. This is basically a replicate of that tutorial, and inside the high fill VOB, the most important noise is this one that creates veins, and the veins in this case is these tight edges that resemble dunes on desert. It's very, this one is the most important one. I will just uncheck it so you can see. Follow that tutorial. It's really good. Either way, I will provide the HIP file for you if you just want to save time and don't generate the desert yourself. This noise is being passed as a mask using the high fill mask by feature, and then that is plugged in the second index of the high fill erode, and that computes some erosion on the desert. Will create also more like cool details, and you know, it will help you to manipulate this value and get different different levels of erosion. Then this node will just convert the whole high fill, which is a volume, to a polygon, and it's cool because it's also creating UVs. And the facet here is generating normals, and then I'm cleaning this with attribute, cleaning all these, you know, attributes that I don't need, and then catching the desert just one frame, and not using the $F4 because there is no animation here. So color, and then transforming this to a value that makes sense to me for the simulation. If you see the grid, remember that this grid, I don't know why I'm not being able to see this here, but you can see it here. It's like every square here is like 1 meter, so we have like 100 by 100 meters of desert. That is way more than enough. Since we're going to be focused on one patch here that we're going to clean and subtract that area. So this is actually more than enough, but it will allow you to find a good area. You can decide where that collision with the car is going to happen. So it's very, very good. So follow that tutorial. For the car, I will show you what I'm doing here. You will also receive a car. You can ask, as an effects artist, as a Houdini artist, you can ask for, you know, separate groups. You can have your tires separated, you know, in different groups, the rims, the tires, the chassis, everything, so you have control of which part of the car you need for the collision. Let's check that too. For the car, I downloaded this one from Turbo Squid, something that I found that works for the tutorial. Basically, it's an OBJ. I did some transformation because it came out really big. I'm trying to keep this, in a scale that makes sense. I will probably tweak this value again in the next geometry network that I'm doing, where I'm separating things. What I'm doing here is just the object. I get tire 1, tire 2, tire 3, tire 4, and then I generate some on X, is the kind of the perpendicular axis that it will work perfect for rotation, because it's the tire is going to rotate on that perpendicular axis in this case, generating a quick frame expression multiplied by 40. This is grabbing, it's a reference, it's a channel reference from my animation. This is where I'm separating the body of the car. This is where I'm animating on this one. Basically, I'm copying, reference, channeling all the animation that I did there. I did some retime. You might tweak this if you need it. You might not need it. Then time shift again, just to get to clamping the last frame. It's usually good to have extra frames in the animation. Also extra, like padding, extra frames for, usually you don't work on frame 1 in production. You work on frame 1001, and that allows you to bring extra frame previews to the animation. That way you can compute velocity and have everything correct. I will tweak this heap file doing that, and reorganize. I mean, the organization of this is good, but I will tweak that so we work on frame 1001, which is the production standard. It's more common than just start the simulation from frame 1. It's too hard to get velocities if you don't have previous frames, right? On this frame, frame 1 won't have velocity unless you do negative frames. So let me tweak that, and then I got the materials. But as you can see, everything is clean and separated. Velocity has been computed using trails that, as you can see, you can enable the velocity guide. I will show you the vectors of the rotation plus translation. So it's, kind of the accuracy of the actual motion of a car tire, I'm sorry. But let me clean this and we continue from there. But let's finish this chapter with this. This is isolating elements, isolating the tires. The tires are going to be very relevant for the simulation, because the collisions are going to, generate some kind of motion that comes from the rotation of the tires. So definitely you need the tires as isolated elements to control them. And then you can separate also the body, where you can do different kind of different arrangements, tweakings, tricks to achieve what you need, actually what the director is going to request, or the effect supervisor, or the VFX supervisor, or the CG supervisor. So it's very important to come up with this step of separating elements. So let's jump to the next chapter.